So similar to the heat transfer, similar are the concept over here, but they are called with a different name. For example, uh, one is advection and one is dispersion. Advection is similar to convection, and dispersion is a kind of diffusion and movement with a we call it molecular action की वजह से जो movement होती है. So before that, let me introduce another parameter which is required for the transport. Transport of the constituent is measured. Transport of the constituent is measured with the help of parameter we call it flux of the constituents. And the flux of the constituent represented by capital F, that is the flow rate per unit area of the fluid. Flow rate per unit area of flow. If it is a river channel, so flow rate of the constituent, not the flow rate of the water. Flow rate of the constituent per unit area of the fluid or flow. So that is called as a flux and represented by F. And if we multiply it with the area, if we multiply it flux with the area, we get the mass flow rate of the constituent. Or if we divide the mass flow rate with the area of the fluid, so we get the flux. So mass flow rate divided by area will give us the flux, or simply velocity, average velocity of the flow rate multiplied by the concentration C. So if U is the velocity of the flow and C is the concentration, we get the units similar to what they have said. It is the flow rate of the constituents per unit area. So U is in meter per second, C is in let us say kg per cubic meter of water, C is kg per cubic meter of water. So end result we will be getting as kg per meter square per second. That will be called as the flux. Flux is the flow rate per unit area, or quantity per unit area per unit time. So this will be the units. Can be kg per meter square second or grams per meter square per second, and we can easily find it by multiplying average velocity of the flow with the concentration of the constituent. Each constituent will be separately handled. Each nutrients or each pollutant can be separately handled. So now transport mechanism, it can be because of any of the three ways, conduction, convection or radiation, but the radiation transport is not of interest to water engineers dealing with the flow in the river. Radiation is the third type of the transport mechanism, not much important for surface water flows. सो इसको इतना हमारे जो रिवर की बुक्स हैं, वाटर क्वालिटी की बुक्स हैं, ट्रांसपोर्ट विद द हेल्प ऑफ द रेडिएशन इज नॉट कंसिडर्ड. Quantities are less and we don't model it. But radiation is important with respect to if we are analyzing heat or energy transport. उसके लिए ये important है, वहाँ पे इसके use होंगे. But the nutrients which are measured in terms of mass or grams per kg, उसमें ये advection or dispersion are important. And we will see that dispersion is more important as compared to advection. So what is advection and what is diffusion or dispersion? Advection is bodily transport. Advection transport occurs because of the bodily transport due to the motion of the fluid. If constituent move from one place to the other place along with the moving fluid, we say this is convection. We say this is advection. So for constituent name is advection. For heat we call it convection. So both are similar. Convection in heat energy was because of bodily movement of the media, and over here we call it advection. So keep in mind that advection is similar to, name is different and used in water quality analysis we call it advection, but concept is same as convection. So velocity controls the transport of the constituent. So here, through this figure, this is a river channel, and some constituent is placed over here. If it is moving along with the, so suspended sediments are usually moving through advection. Suspended sediment which are not dissolved, so they are usually moving with the help of advection. So if it is moving along with the water because of the velocity of the water, so then we say this is a process of movement or transport known as advection of the nutrients. So if there is a constituent whose concentration is 2 grams per cubic meter, just for example, there is a constituent whose quantity or concentration is 2 grams per cubic meter, and the velocity of that channel is 3 meter per second, we can say its mass flux is C into U, so that will be 6 grams per meter square per second, 6 grams per meter square per second. So similarly, this concept can be used, this advection and this flux concept can be used for transfer of the heat energy also. So the second part of this paragraph tells you how to calculate the flux with respect to heat energy. The first part have told you how to calculate the mass flux with respect to a material constituent, mass constituent having units of grams per cubic meter, but this can be used for heat energy transfer also. They have said that, for example, heat flux in water having a temperature of 25 degrees centigrade and the velocity of 3 meters second can be calculated. Heat flux can be calculated. So if it is a heat, what will be the unit of concentration? Can you tell me? If it is a heat, what should be the unit? Because usually we say concentration is measured in grams per cubic meter, and grams are the weight mass of the constituent, and cubic meter is the volume of the fluid. So heat energy should be measured in what concentration units? क्या ख्याल है?
किलो जूल्स पर।
जाउल सर।
So ये joules पर क्यूबिक मीटर होना चाहिए या कैलोरीज पर क्यूबिक मीटर होना चाहिए? So हीट के यूनिट्स होने चाहिए, BTU होने चाहिए. तो they have given us the temperature, so we have to convert first this into the heat energy. If a water body is having 25 degree centigrade of temperature, how much heat energy it is carrying? पहले तो हमें ये कन्वर्शन करनी पड़ेगी, इसको कंसंट्रेशन की टर्म्स में लाना पड़ेगा. So that can be converted if we know for water how much is the energy required to raise its temperature by 1 degree centigrade or reduce its temperature by 1 degree centigrade. So this thing is called as इस चीज को क्या कहते हैं? Energy released or absorbed for a unit degree change in temperature by a unit mass of the fluid. इसको कहते हैं, क्या कहते हैं इसे? इसको
स्पेसिफिक
कहते हैं CP, इसको कहते हैं हीट कैपेसिटी. ठीक है, तो वी हैव स्टडीड दिस थिंग इन FSC मैट्रिक एंड दीज आर द, इसको क्या कहते हैं, हम यादें कर रहे हैं उनकी चीज़ों को बार बार. सो अब अगर FSC वाला कोई पूछे कि मुझे ये क्यों पढ़ा रहे हो CP, तो उसको बता देना कि आपको CP क्यों पढ़ा रहे हैं. If we want to analyze the real life system, if we want to analyze the transfer of the heat energy along with the moving water, so how you can get it, important parameter. अगर कोई पूछे मुझे density क्यों पढ़ा रहे हो, तो you can well answer. Okay, तो यहाँ पे मैं देखना चाहता हूँ इसकी डेफिनेशन नीचे लिखी हुई है कि नहीं. So इसी लेक्चर में नीचे लिखी हुई है डेफिनेशन, heat capacity which is represented by CP, hopefully you are seeing it, is the energy to be supplied or released for a unit change of temperature per unit mass. Energy supplied, अगर हमने temperature बढ़ाना है तो energy required or supplied. If we want to reduce the temperature, then energy released by that water per unit mass of that water or body per degree centigrade. So for water, CP is said to be 4.2 kilojoules or 4200 joules per kg per degree centigrade. So if I multiply this 25 with this Cp, what I will be getting? 25 degrees centigrade has heat energy of 4200 into 25. Answer will be joules per kg. Answer will be joules per kg. 25 degrees centigrade multiplied by 42,000, 4200 multiplied by 4200, 4.2 thousand will give me joules per kg of energy contained by a water, 1 kg of water uh, at 25 degrees centigrade. If a water is at 25 degrees centigrade, this much heat energy it is carrying. So I need concentration in joules per meter cube. This is joules per kg है. इसका आंसर क्या आएगा? joule per kg. So convert it into the joules per cubic meter of water. I have to multiply it with the density of water. So all this thing on the U into this part rho Cp into T is converting temperature into concentration of the heat energy. Got it? This rho Cp into T is converting temperature into heat energy per unit volume of the water. That is the concentration of the heat. Got it? So first you find the concentration of the heat, C, of the from the temperature, from the heat capacity, from the density, and then multiply it with the velocity in the normal way as we do to calculate the flux. Flux is U into C. So that is how you can find that if a water body is moving with 3 meter per second speed and temperature of that body is 25 degrees centigrade, it is transferring 3 or 0.3 billion joules per meter square per second. So if I multiply it with the flow area, you can find how much is energy going. If it is a 1 meter square channel, so you can find how much energy is being transferred per second. Maybe if you transfer that water to 0 degree, you get this energy back. Okay, so that is how this concept of flux can be used to see the movement or transport. And for advection, because it is moving along with the flux can be calculated using simply the velocity of the water. Flux can be, so when flux is known, so it means I can know after how much time it will reach downstream side, when it will be reaching at what place. This is per second. So this is a movement of the energy per second. So I can analyze for advection using this concept of flux U into C.